Hello, geometry students. Mr. Zacek back and better than ever with you here. We're in Unit 3, Lesson 2-3. Now, just to kind of take you on the journey, in 2-1, we defined angles, okay? And in 2-2, we talked about given parallel lines, we have kind of angle conclusions. So, given two lines are parallel and cut by a transversal, then corresponding angles are going to be congruent. Today, in this lesson, we're going to flip this around and we're going to look at how do we prove that two lines are parallel. So what we're doing here, and we've got three reasons that we can use. All these things that we see right here. Whoops, I don't want the highlighter yet. All of these things right here are reasons. Okay, and when we do the proof, these are going to be the reasons. But what I want to point out to you is we have essentially switched around the hypothesis and conclusion. So we've put this corresponding angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary. We've put that ahead of the then the lines are parallel. Then the lines are parallel. Then the lines are parallel. So in lesson 2 it was if the lines are parallel, then these angles are congruent or these angles are supplementary. In this lesson it's if these angles are congruent or if these angles are supplementary, then the lines are parallel. And so we're switching it around. In logic, that term is called the converse, where we can switch those things around. Okay, so again, let's identify, what are we trying to prove here? We're trying to prove parallel. And what are we given? We're given that angle 1, so I'm going to mark this, is congruent to angle 2. Well, we want to recognize that angle 1 and angle 2 are corresponding angles. So angle 1 and angle 2 are corresponding angles. And because they are congruent, that means the lines are parallel. So this is a short, really straightforward one. Angle 1 and angle 2, okay, that's given. So the conclusion we can make in our next step is that line L is parallel to line M. And the reason, we're just going to copy it right up from the top here. If two lines are cut by a transversal, such that corresponding angles are congruent, then the lines are parallel. So it needs to finish with the lines being parallel because that's what we've said back here in statement 1. Okay, one more example. Given this, can we prove that? And this is going to follow kind of the same setup here. And what we want to recognize in this scenario is we want to recognize that angle 1 and angle 3 are alternate interior angles. And therefore, the lines are parallel because they're congruent. So angle 1 is congruent to angle 3. That's our given. I should write up, okay, statements and reasons. So now, we're given that's true. We know it's true. Therefore, the conclusion is that L is parallel to M. Okay, and here's the reason. If two lines are cut by a transversal, such that alternate interior angles are congruent, alternate interior angles are congruent. Okay, then the lines are parallel. Okay, so again, we're just flipping around what we did in the other lesson. Okay, now let's get a little more complex here in this type of scenario. Here's where things start to get a little more challenging, and we have to kind of develop more of a plan here before we just sort of go ahead and jump into it. Okay, we are given that T is parallel to S. Okay, that means this line is parallel to this line. I'm going to use a highlighter. What I would recommend for you is that you even take your paper and turn it. Do a rotation so you're looking at T in parallel, like a 90-degree rotation to help you see this. People have a hard time with this. Okay, now here's the key to, whoops, I just moved my little recorder thing. I think I'll be okay. All right, here's the key to these questions. The key to these kind of questions is to identify the transversal that we're talking about. Okay, so because the angle pairs happen along the transversal. So let's also mark our other given. So I've got 6 and 9. Okay, now 6 and 9 are not on this, they're not on the same transversal. So if I'm trying to prove L parallel to M, which we are, okay, this is what we're trying to prove, I need to get something along the transversal, the same transversal. So here's how we can do this, okay? Since T is parallel to S, here's a transversal that cuts through that line. Now, if two lines are parallel and cut by a transversal, then we know some conclusions. One of the conclusions is that angle 2 would be congruent to angle 9. Those are alternate interior angles. Well, if 2 is congruent to 9 and 6 is congruent to 9, then 6 and 2 would be congruent to each other, and because of that, the lines will be parallel. Okay, and that might be a lot to just kind of keep straight in your head. So let's go ahead and write this out. Now I know that my reasons in this case are going to be longer than my statements. So in these, proofs, sometimes I just kind of offset, let the reason side be a lot longer. Okay, let's start with what we're given. So we're given T parallel to S and angle 6 congruent to angle 9. Okay, given. Now, again, we have to go along a transversal that's through the parallel lines, which is this blue highlighted line. So here's the conclusion that we can make. That angle 9 is congruent to angle 2, and that's because T and S are parallel. So if two lines are parallel and cut by a transversal, all right, then what kind of pair is 9 and 2? 9 and 2 are alternate interior. Okay, then alternate interior angles are congruent. Now, since 6 is congruent to 9 and 9 is congruent to 2, we can say that angle 6 is congruent to angle 2 because of transitive or substitution. Either one of those will work. Okay, so now that we have that, okay, now here's what we're working with. We're working with 6 and 2, and what I want you to notice is, let me get my highlighter back here. Okay, these are the lines we're trying to prove. So I need a pair of angles along the transversal, one transversal that cuts through, and line T is that transversal. So what are angles 2 and 6? They're corresponding. If corresponding angles are congruent, then the lines are parallel. So I can now say what I'm trying to prove, which is L is parallel to M. And the reason is, if two lines are cut by a transversal, such that corresponding angles are congruent, then they are parallel. Okay, so I want to bring your attention to, in these reasons, the difference between then alternate interior angles are congruent versus then they are parallel. Okay, so in 2, it was because we were given parallel, we made a conclusion about angles. In statement 4, or reason 4, it's because we knew something about angles. All right, and where are those angles? Just to help you clarify, this is, okay, that's what we said in step 3, that the corresponding angles are congruent. Okay, now I've got like 2 minutes to do this next one because the bell is going to ring, okay, and I want to get it done before that. So let's see, we've got here T is parallel to S, okay, so T and S are parallel, and 6 is, whoops, wanted a pen there. Okay, angle 6 is congruent to angle 11, and we can essentially do this one the same way. I'm just going to show you a slightly different way to do this now. Instead here, I'm going to go from 11 up to 3, because 11 and 3 are corresponding angles. So let me see if I can kind of take this through here. Okay, so number 1, let's do our givens. All right, T is parallel to S, angle 6 is congruent to angle 11. Okay, that's given. All right, now because T is parallel to S, in step 2 I can say angle 11 is congruent to angle 3 if two lines are parallel and cut by a transversal, then, okay, what kind of angles are angle 11 and angle 3? They're corresponding. So then corresponding angles are congruent. Now, what conclusion can we make next? Well, we can say that angle 6 is going to be congruent to angle 3, okay, by the transitive or by substitution. Either one works. Okay, now 6 and 3 are along, so 6 and 3, here's the lines we're trying to prove parallel. Here's the transversal that cuts those. 6 and 3 are a pair of alternate interior angles. So we can say that L is parallel to M, and the reason is, if two lines are cut by a transversal, such that, if two lines are cut by a transversal, such that alternate interior angles are congruent, then they are parallel. All right, and there's the bell. So we got it in. All right, this one's tricky, so if you have questions, please ask, okay? It's a little tough. Now, don't expect on your assignment, sometimes the given is going to change, and sometimes in this diagram, we'll start with L parallel to M. So we got to kind of work our thinking around there, okay? Good luck with this one. This one, it's a little tricky there, so make sure you work diligently at it and ask lots of questions.